Here's integrated 3. This is problem 10-13. So it wants us to write a possible equation for each graph. And so I'll start with graph letter A. So I'm gonna try to use graphing form, and I can use sine or cosine, and I'm going to find out what A, B, H, and K are, and then write it in graphing form. So the way I decide whether I want it to be a sine or cosine function is I'm kind of using these dots that they give me as a hint, because sine, the parent function of sine, it always starts at the origin and it hits the midline 3 times like this one does. So I think I want to use sine for that one. This one reminds me more, this is y equals sine x. This one looks more like a cosine graph to me, because cosine kind of goes, that's what the parent function looks like. So it's got like, right, this one has three points on the midline, and then it has a high point and a low point. Cosine has 2 points on the midline, and then it's got 2 high points and 1 low point. So this one kind of reminds me of, see how like this part, that's this. Because if I made this go over to the other side. So like for this one I'm going to use a sine graph, and for this one I'm going to use a cosine. You could use either for, yeah, I mean, because you can move them around. But let's just do this one with a sine graph. So I'm going to find out what, I like to find out what K is first. So K is going to be the midline or the centered line, and it's 2. So I know K for letter A. I know K equals 2. And H is going to be, this is like the locator point. So H is going to be whatever that little increment is right there. So if this is pi over 2, that must be pi over 4. Okay, A is going to be, A is the amplitude, so it's how far up and down from the midline. These are counting by halves, so I guess that's just up by 1, and so A is just 1. I think B is also just 1, because B is going to be 1 if from the beginning to the end equals 2 pi. And I know it's kind of hard to tell, but it really does equal 2 pi, because see how this is shifted 1 past 2 pi, but this is shifted 1 past 0. So the total distance from here to here is 2 pi, so B is just going to be 1. So if I put these all together, I'm going to have y equals a sine b x minus h plus k, right? But so we said a was going to be 1. So I'm not going to write the 1 though. And then b was 1, so I'm not going to write that. And I'm going to go x minus h plus k. I said k was 2. Check that. Yeah, and there's lots of ways to write it. Okay, so that was letter A. Okay, so now we're going to do letter B. Letter B is this graph. So on this graph, I already said I was going to use cosine. I want to check the period, like see how this point and this point span from negative pi to positive pi. That tells me that the whole period is 2 pi. So I know that B is going to also equal, actually let's do letter B right here. B is going to equal 1. What's A going to equal? Well, A is the amplitude. So, oh, gross. It's going to go from 0.5 to 2, because that's 0.5. So that's 1.5. And then H, I think H is just nothing, because the locator point is going to still be on the y-axis. And K, this thing is lifted up by 0.5, so K is going to be 0.5. So this is, I said I wanted to make this a cosine graph, and I know it goes like y equals a cosine b times x minus h plus k. So I said a was 1.5, b was 1, so I'm not going to write that. H was 0, so I'm just going to write x, like x plus 0 or minus 0, plus 0.5. Yeah, that's right. And if you ever are checking your math and like, let's say somebody's correcting your math and that it doesn't match the answer key, you can put it in Desmos. This actually is correct, even though that doesn't match your answer key. You can put the one that's in the answer key into Desmos, and then you can put this one also into Desmos, and you will see that they will fit exactly on top of each other. They're the same graph. Okay, so now we're on letter C. I'm going to fold this over so we can do this better. So letter C has these 3 dots. So I feel like using a sign graph whenever I see it looking like that. And so I'm going to say, what do I have? A, B, H, K. Let's see if we can fill out some of these. The amplitude, if this is the midline right here, 2 is the midline, so we'll put that in for K. And then the amplitude is, it goes like, it just goes up by 1, so that's, and then B, we're only going to change B, like B's going to be 1 unless this has a period of something other than 2 pi. But I think it's going to also be 2 pi, because see how that's just scooted over to the right by 1 little click from negative pi, and this one is scooted exactly the same distance from positive pi. If I just scooted both of them over 1 click, one section, it would be negative pi plus positive. That's 2 pi. The distance between these 2 points is 2 pi. So I'm just going to let B equal 1. Now H is it's like if there's a shift, a horizontal shift. And this, if that's my locator point, because sine graphs go like this, that's my locator point. That one, that's my locator point on this one, and it's moved to the left. So I had to figure out how far to the left is it moved. So I looked from 0 to pi, negative pi, and I count like, how many spaces are there? 1, 2, 3, 4, 5, 6. So they're counting by sixths. So 1/6, 2/6, 3/6, 4/6, 5/6. So that's 5 pi over 6 right there. Okay, so that's a horizontal shift. And it's shifted left. So I think anyway, let's put this in our we got y equals a sine b x minus h. So we said a was 1, so we won't write that. So b was 1, we won't write that. So it's shifted left, so I'm going to write plus 5 pi over 6. And then it's up by 2. And I am running out of time, so I'm going to do this well, no, I'm going to make another video for the next, for problem D.